Hello guys, featuring the ESP32 Doit development board. So this Doit development board features the ESP32 microcontroller created by Espressif. So it is a low-cost development board that features low power capabilities, has Wi-Fi capabilities, Bluetooth including Bluetooth Classic and Bluetooth Low Energy. It features dual-core ESP32. It features rich input and output interfaces as we can see in its pinout. So it has a lot of general purpose input and outputs, ADC, some UART, multiple UARTs, SPI, I2C, and PWM outputs. It is also compatible with Arduino programming and compatible with MicroPython. So you can use this in a lot of applications, especially for those applications that need some wireless capabilities. In this video, we will show you how to develop a simple program for your ESP32 so that you can control it using your Android phone using the RoboRemo application. So in this, you can see that we can control the LED using the sliders and the buttons in our smartphone. For this demonstration, we'll be using an ESP32 Doit module, two red LEDs, 220 ohms resistors. LEDs and resistors are connected to pin 19 and pin 21, and some jumper cables for our ground, and some good quality USB cable. So for this demonstration, we will be using the ESP32 and its Bluetooth Classic feature to control these LEDs using our smartphone. Okay, for the initial setup of our Arduino IDE, inherently Arduino IDE does not support ESP32 devices after installation of the IDE, so kailangan natin mag-add ng boards for our Arduino IDE. So what we're gonna do is magkalagay tayo ng additional boards manager URLs dito sa ating entry box here. So if you already have some items here for your boards manager, so you just have to paste your boards manager for the ESP32. So in this case, I have a multiple URLs, so I have just separated them using a comma. Okay? So look for the ESP32 boards manager URL and then go to the GitHub link. And then on your GitHub link, just copy the stable release link for our ESP32. Then copy it in our preferences, additional boards manager. Then if you have some other boards manager, then you can paste it here. Just separate them using a comma. So comma, then paste whatever you have for your boards manager. So after you did that, you should be able to see some options for the boards for your ESP32. All right. Okay, for the ESP32 Doit, we will be using the option for the ESP32 dev module. Right? So before you select that module, it is best to connect your hardware into your USB port. Sometimes it automatically detects that. If it does not detect ESP32 dev module, so you just have to search it here, dev module, and you can find that ESP32 dev module. Then select the proper COM port. All right. So once we have set up our Arduino IDE for our ESP32 hardware, now set up our RoboRemo because we will be using RoboRemo to control our ESP32. To do that, so we will be needing one button to control our LED, one on-off, and then another slider to control the brightness of the other. Okay, on-off and then slider. So to do that, I will be just editing the RoboRemo, then add two buttons. It's button 1. We will call that. We will select a command A whenever we press that button. So we will call this on. Right? Okay. And then you add another button. Then we'll call that off. And then the command for the press will be B. So those letters that I have indicated will be the data that will be sent to our ESP32 hardware. So later we will check if that is correct. And then we will add another slider, right? And we will have an ID C to indicate that the data will start with C. It will send 0 to 255 values for the slider. And it will not send space after ID. All right, so now we have basically set up our RoboRemo. All right, so after setting up our RoboRemo, so we will now proceed to program our ESP32, a simple code, so that whatever data that we have received from our RoboRemo will be reflected in our serial monitor. And so to do that, we have this code, all right? So basically, you have just set up our ESP32. It's Bluetooth Classic to be named as ESP32 BT Classic. So we will have a copy of this program in our links. So once program is already loaded to our ESP32, we will now test if we can detect our ESP32. It should be named as ESP32 Bluetooth Classic. All right. So in our cell phones, we will open our Bluetooth. Okay. And more. And we will search for our device. As you can see, I can detect this as ESP32 Bluetooth Classics. For our program, it will automatically pair. So there is no need for any pairing code in this program. All right. So once we have paired our device, ESP32 Bluetooth Classic, we will go back to our RoboRemo. All right. Menu, connect, RFCOM, and look for ESP32 Bluetooth Classic. All right. And you should be able to connect to the ESP32. Now, once that's done, we will monitor our serial monitor from our computer. And we will try to see if our program coincides, the RoboRemo buttons coincides to what we have set up. Okay? Right. So for the on, we needed A. There, received A. For the off, we needed B. And for the sliders, it will send letter C and all of the values of the slider. All right? So after this one, we just need to create a program to decode everything, and we should be good to go. A digital output and a PWM output for our ESP32. Now, ESP32 has a lot of PWM outputs, so we can set the channels and the duty cycle of each output, and we can also select what digital output pins that particular PWM value will go to. So we have here a bunch of setup. So for our digital output setup, so we have LED pin 19 for our digital output. All right. And for our PWM properties, so we have frequency of 5,000. It will be using the LED channel 0 and the resolution 8. And then you have set up our 2 pins for digital output, our Bluetooth as ESP32 PT Classic. And for our void setup again, we are setting up the channels for our PWM. So the LED channel is channel 0 from our initialization, right? And our frequency is 5,000 hertz. And of course, our resolution is an 8-bit resolution. So we are following the 8-bit resolution also from our RoboRemo, which is from 0 to 255. And we will attach that particular PWM channel to our LED pin, which is indicated as pin 19, right? And our LED channel is for still 0. Okay, for our void loop, we have created a program to detect if there is any available data from our Bluetooth. We called my Bluetooth my BT, and it will receive that data, and we will analyze if it starts with A, B, and C. So if it starts with C, we have a bunch of categories. If there are 4 characters, so we will decode for 4 characters. If we have 3 characters, we will decode for 3 characters. And if we have 2 characters, we will decode for 2 characters. All right. So we have a mistake here. Case 2. Okay. And that's it for our program. In each case, we have to decode the value of the brightness that is set by the RoboRemo slider. And we will write it in our PWM pin using the LED C right syntax. And just to see the values, we will also monitor it using our serial monitor. So let's give it a try. So I have pressed upload, and I will be waiting for the compilation. Right, it's now done uploading, and we will now try to see if our LEDs respond to our RoboRemo. Right, so menu, you have to connect, RefCom, go to ESP32 Bluetooth Classic, and they will try to turn it on. There, off, and then sliders. So dim, dim, and up, 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 dim, 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 up, 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 up. Okay, so that's how we do a simple Bluetooth Classic project for our ESP32 Doit.